So let's see. The claim on this one is it's the same as. So that's the percentage equals 0.845. Does that have an equal sign in it? Yes. So where's it going to go? HO. So what's going to go in here? Not equals. H1 is always the statement that I can show evidence for. I cannot show evidence that something equals something. I can't. Because the sample is always going to be different from what the real meaning is. I can't show it's evidence that it equals something. But I can show there's evidence that it doesn't equal something. So this guy can never have the equal sign, because I can't show evidence for something equal to something. That's why it works the way it does. Write the claim, put it in the right spot, depending on if it has an equal sign or not, and then the other guy is the opposite, because they don't agree with each other. Right? How many tail test is it then? Two-tail test, because you can be less or greater, and that means it's not equal to. We used to use this symbol here, but math people, we don't really like using multiple symbols in a row. Right, but that's kind of like greater or less than. That kind of shows you a little more directly that it's both ways. What do I check here? What's N? 322? And what's P? 0.845. Is that 5? So what's 322 times 0.845? 272 roughly. That's at least 5, and then this is going to be 50 roughly. That's at least 5. So what's that mean? Normal enough. I could do something. What can I do specifically? Use z-scores. I love it. Never use t-score with an NPQ problem. Jeez. Alpha for this was 0.10. Now, and I know it's a two-tail test, and I know I can use z-scores. So of course I use a t-score chart, because the top of the t-score chart is set up for any hypothesis. Beautiful. But if I want a z-score, I just don't stop. Right? Just go all the way to the bottom. So if I look up 0.10 in the two-tail column, I should get, yeah. Now, some of you guys were trying to do a little too much work because you're used to having to. If you want to use the z-score chart, what would I look up in the how much is in here? 0.05. Right? So if I use the z-score chart, I have to look up 0.05, and then you should get this. Some of you guys are looking at 0.10, and that's a totally different problem. There's not 10% below anything in this picture. There's 5% below something in this picture. But why use a frickin' z-score chart? Some of you guys are still kind of like, because I want a z-score, man. T-scores have z-scores on them. At the bottom. I love it. I'm not talking to anyone in specifically. I know I talked to a few guys about this. I'm not talking to you. There's a lot of people that have that. So how do I say that in words? Wait, help me out. What do you say? That's impossible, right? P is a percentage. If Z star is greater than 1.645 or less than negative 1.645. Now really, no. Then we can reject who? The ho, support the high. Now trust me, gotta trust me. I totally understand how you can get buried under details and forget the idea. Which one of these things thinks it's in here? The hoe does. So if I get a sample that's way the shit out there, who's wrong? Oh, okay, so if I get above that or below that, he's wrong. Well, that's evidence he's wrong. Which means it's evidence the other guy's right, because the other guy thinks it's out there. It's that simple. It's that straightforward. It's easy to kind of get so buried in a problem you forget that there are things about this that just makes common sense. I understand that, trust me. But that's why we do things the way we do. That's why we say the things we say, because that's the idea of it. Okay, maybe. So now that I've set up what far enough away is, I go see how far my sample got. I think I'm really pushing you guys today. So what do we know from the sample? What's p hat? P hat. 0.814? I like it.
0.8137.
So you can do 8137, 11 if you want to. I don't want to. So you can round it to 3 places, or like I said at the beginning, you round everything to 4 places. It would be golden. Do I need Q hat? No. Don't care the shit about Q hat. I don't. And you're like, I never do, dude. So P hat minus P. So our data minus the claim one divided by the square root of all this. Here's P. Q we know. Wait, get out of there. Here's P. Q we know. Over, what was that, 322? So P hat only shows up in one place. Right there. And what do you guys get? Yeah?
Negative 1.55.
Negative 1.5. 5 or 4, I think, depending on how much you rounded.
I think I may have did 3.
We did 4.
Right?
537.
I may have did 4.
537.
Oh, yeah, okay. All right, so again, it could be multiple answers based on how much you rounded P hat. Are you guys with me? So obviously I would take whatever you did. And if you did it correctly from what you did, you're fine. That would change the p-value a little bit depending on which way you did it. Now, I really want this. I don't know why I ever say this, because of course I always want every damn thing I say to make sense. But I really want this to make sense. In order to be fair, what did I have to do to alpha? I cut it in half. So there's 5% in this tail. I would double it to get back to where it was, right? So the p-value is in that one tail. Here's negative 154. So I got to double it for a 2-tail test. And the real reason is, all right, let me see. If the p-value is small, am I further away or not? The smaller the p-value gets. What's the p-value mean? It's the area in the tail. So if the p-value gets really small, then my z-score must have been really far away. How do I make the tail smaller? Don't I get further and further and further away to make the tail smaller? Okay. So that's why a small p-value is strong evidence. That's why you see in an article p less than 0.0001. They're like, look at this shit. So they want to, it's like really good evidence. So, if I get the p-value, I got to double what the chart tells me for that. Let me look that one up. 06 something, right? 0618. So if I double, I get 0.1236. I love you guys so much. Now think about it. If my z-star would have shown up in here, wouldn't its p-value have been less than alpha? If my z-star was in here, it has a smaller tail then, wouldn't its p-value be less than this? All right, so the direct way to see the answer to a hypothesis test is look at your freaking z-score. Is it far enough away? You got the answer. I understand that. Answer's done. The other way to do it is if the p-value is less than alpha, then you can reject the null also, because it means the same damn thing. If the p-value is less than alpha, then your z-star must have been further away. They mean the same thing. So why do I double this at the end to make this comparison fair? Because then I have to cut alpha in half. So you got to double the p-value so I can compare it to the whole alpha. Right? Now, if anybody is kind of still with me, I could have just freaking used the p-value and compared it to half of alpha. Mathematically, it doesn't matter, but we just decided to say this. Double the area to get the p-value. Okay. So isn't 0.1236, isn't that less than 0.10? Jeff, try again. Greater than 1.10? That's greater. It's not less. So it's another. So right now, we already know we failed. Right? Because we didn't make it far enough away. But this also says, oh shit, look, that's bigger. It's not significant enough. That's another way of saying, hey, you failed again. Hey, shit. Yes?
Just the difference is only for two tails. One is two tails.
Two tails is when you double it. Otherwise, you just compare them.
And that could be for the non-NPQ.
Totally. Yeah. Anytime using z-squish, yeah. All right. So right here I can write fail to reject the null, fail to support the high. Right? Cool? Right? I would definitely write that. That's not good enough for part E. Don't put that shit on part E. But right now I can interpret what the hell I just did. Which language am I going to use? The top one or the bottom one? Why? Because our claim was the null. So we're going to use this language. Here, I won't lay it down. We have not found sufficient evidence to reject the claim that the percentage of professors is the same as the students, 84.5%. Yes?
On D, where it says X equals, what number?
Oh, X is the number of successes. So that would be the, what was it? 216? Yeah. Whatever it was, 262. I forgot what it was. Let's take a break. And then when we come back, we'll do the formula sheet. I'll give you the answer key for the practice test. I have more hypothesis test examples if you want to focus on those, but we can just focus on whatever you want to review. So come back, 10 after, come back.
So we're not going to go over that?
We're not going to do what?
10 today?
We'll find out when we get back. I'll say something about it. I love you guys.